Good morning, my friends. It's Roger once again, Mudfossil University, with the most delightful, entertaining investigation I have done in a long time. Now, I got a thing from a lady, Brenda Vieira, very nice lady, and she sees in 3D, literally 3D, not just like everybody else can see focus and distance and see the forms and stuff. She sees colors in 3 dimensions. And here's how it works. She stands and she looks and she sees the red on the top of the table, a yellow up like say a couple of inches in the air, and green a couple inches above there, and if there was blue a couple inches above there. Now, why is that? She sees rainbows. Literally, she sees rainbows. Now, we see this. Red, yellow, green, right all on the, you look down, you see that. You look at this right here. What do you see? You see all the same thing. Well, she sees the blue way out here right in front of your face. And she sees a yellow down in here and a green somewhere in the middle and a red at the bottom. And she says she went to take a driver's test, and she's noticed this obviously through her life, but she looked at the red, the yellow, and the green for the traffic lights, and she sees this, and she said, do you understand this? And I said, no, I don't. But let's take a look and see. So, so I started digging in, reading about who ever had this, and I can't really find anybody that's ever had this specific thing. But there is a lot of research on vision problems. Now, hers is not a problem. This is an ability that we just don't have. She is literally seeing the wavelengths of the light. The red is very long wavelength, and it's just not very strong. Yellow is a little stronger, green is a little stronger, blue is a little stronger, and then it goes up from there. So now, this became extremely interesting to me. So what did I decide I would do? I said, would you do me a favor and look at the pictures that Rodney Warren took using red lasers? If she can see these things in different distances, she will see our light experiments as like she was inside of them. And that is exactly what happened. So here we go. All right, now before I get into this discussion about Brenda, who can see in these light frequencies, you have to understand the electronic model, the atomic model right now, the Bohr model. It's absolutely insane, literally insane. There are not just one gigantic proton and then one little tiny electron floating around in space to make one hydrogen. That's nonsense. This would be one big piece. No, it's 1,836 or 1,837 pieces, because 1,836 is 918 of each positive and 918 of a negative, and then one extra one makes this become net negativity. That keeps one orbiting around in the outside. That is hydrogen. Now, I can prove this, and anybody with even a half a brain can understand. It's impossible to say that this is one chunk and that's one tiny chunk, a huge one and a tiny one, because there are isotopes of hydrogen with all kinds of different properties that are different weights. How do you make this into a whole bunch of different weights? You do it by taking each one of these little bits and pieces and adding one or taking one away. There is no other way. End of the story on that. Right, there's hydrogen isotopes, all kinds of different 1, 2, 6, 7, 4. They're all over the place. What do you see? Lanthanum. There's isotopes of lanthanum. Look at this. These are the transition metals. Look at this. Every one of those is a different lanthanum. Alright, so in all different voltages and weights and spins and polarities and all of this, look at this. Every one of those is different. Now, how do you account for that? Here's how you account for it, because every proton is 1,836 of these pieces. All right, let's pay close attention. At 1836, it's stable. It's resonance stable. The magnetism forces that push in and pull out have a propensity to remain locked together at 1836, which is 918 of positives, 918 of negative. And it appears that the negatives surround the positives. It's called electron flooding. And at that point, that electronic negative coating keeps orbital electrons away, because these are negative too. They can't get there. And I show this with tractor beam magnets. So at 1836, and then another 1836, and then another 1836, and that allows for these things to be broken up in all kinds of pieces to end up with this kind of stuff. Isotopes. There is no other possibility. They have upspins, downspins, the decays, the daughters, the polarities. It's just, there's no other possibility. You can't have gigantic chunks like that and a couple of little chunks and make all this stuff. It just doesn't happen. Every single thing there is made of two particles. An upspin one of these and a downspin one of these, which is a positive and a negative. They add together just like that to form photons. They're back-to-back dipoles. Seen them, and you're going to see them again. This completely demonstrates electron flooding. Here you have the nucleus, and in the center is your positive attractiveness, and you have negative particles that surround it. That is my atomic model. And here is what happens in the quantum world. Bang, right there. Alright? Now, just so you understand, you could have, depending upon how much in the core you had, it would increase the number of electrons on the outside. This is obvious as that. The positiveness of the core continues to attract. And what you're seeing now is heat. When that thing vibrates and shakes, that means things are pushing around and coming in and banging around into the molecules. And it will shake like hell, and that is heat, vibration, and then when it flies away, it is light or electricity or static or lightning or whatever it is. But once it goes, boom, that's it. It's done. Alright, this proves the electron flood theory as far as I'm concerned. If somebody can come up with a better explanation of what I'm going to show you than what I present, I want to hear it. This is light from a red laser. These little dots in the air are free electrons that would collect on you as static, but they are now becoming concussed by that wave coming through the air, causing them to glow. The only part of the there's a particle right here, zip, coming through here, particles. Just a little beam of them, and here they are. Right there, zip straight across. Now, that was the wave. These are the particle streams. Those are particles. They are not waves. They are particles. They're little tiny particles. And they glow because they own a region surrounding them, which is enormous. It's like almost this big, and the particle is this big. When they come flying through the air, everybody's got to get out of the way. They concuss, they glow. Now, this is re-radiated electronic concussion waves coming backwards. That's what this is here. You're seeing that's a reverse EMF, electromotive force. Now, I'm working right now with a girl that can see depth of frequencies of light. When I say that, when she took a driver's test for the red, the green, and the yellow lights, the red is deep down here, she says. The yellow is up here close, and the green is up right closest to her. She sees them in depths, and she sees writing like that, numbers and everything, and letters. When there's this bold, it's very, very amazing. And I'm into there's a lot of research on this. About 2D and 3D vision and different focal, all kinds of stuff. We'll get into that later. It's a very exciting time to be looking into this. But anyway, let's get back to this. This is the light. This is the particles. Again, they're concussing. If you could see, these are all little tiny particles. Now, this is the plasma. This is the Cherenkov radiation. Exactly what CERN asked for. These are the Higgs fields. Exactly what CERN is expecting to see. These are the boson spinning charged particles that carry the field, which is here. That's what CERN says they want to see. Over here, this is something that CERN has no clue about. Nobody else does either. Because that is a reverse spinning particle that came through this up here, and there was a white particle up here. I'll show you these because this is very interesting, and I'd love to hear somebody give me an explanation for this. This is the norm. These here, these are Higgs fields. That's the norm. That's light spinning off into the Never Never Land. This is a reverse spinner, and it crashed into this field. Now, and I had her look at these pictures with her eyes that can see these things. She says these things are floating up in the air, and she sees this like a Jax. I'll show you the pictures she sent to me. We've been going through this, and I'm just getting started with it because she just absolutely, this has floored me. Now, this is the particle spinning to the right, drifts to the left. You can see it's expanded down here, crushed up there. That means it's compacting as it's slowing down. So light can speed up. Light is a particle. Light has these Higgs fields, and that is exactly what CERN wants. Here's the, first of all, here's the Cherenkov radiation. I showed you that. Okay, here's what we have right here. Electron, neutrino, electron showers. We're shooting light. They're electrons, you know, in the photon electron range. The Cherenkov radiation, electron shower produced by a high-speed particle. This is electron neutrino, high speed, smashes into the atmosphere of space, shatters all that stuff. Now, this is their high-speed one that they use at CERN, which is 8,000 times heavier, or somewhere in that area, 4,000. Anyway, and here is the Higgs. You saw the Higgs I showed you. This is the Higgs they have. Now, here's what they're doing, though. They're taking two particles coming head-on, boom, and they get that. I'm doing the same thing, only I'm taking a particle and shooting it through and making it crush itself into this slot and wrap around and smash into itself as it goes through, and it comes out the other side just like you're seeing. And I have the Higgs fields on the other side. Now, just so you're clear, that's the same Higgs fields as CERN sees because they are the same particles. They have bigger ones, I have smaller ones. No difference whatsoever. They say these exist, they just can't find them because they're looking in lead to find them. These are existing. This is right in the middle of the air. Rodney Warren took these in Australia years ago. I've been working with these for years trying to figure these out, and I now have what I feel is a good handle on what's happening here. That comes out the Cherenkov, as CERN says. It has been accelerated, which is all it is the stuff they're doing is accelerating something, and the acceleration happens with them because they get it up close to the speed of light. When they hit them head on, you got more than the speed of light. Now, these are the little bits of particles coming out of here, sizzling away, carrying the charge, which as it hits the particles that are in the field surrounding it, which is just our atmosphere, which has these free-floating electrons. Those are the static charges that are in the air. They collect on you. They're just floating around. They want to be involved in anything that needs an extra electron. They're all over the place. It's ether. When this little sizzling, spinning particle with its charge on it hits that ether, it just whips it up like whipping up a ice cream. And you get these little polar particles spinning like this, and these are little charged particles that are bouncing away from that spinning particle. So this is what's created from the Cherenkov radiation. CERN is happy with that. Boson, CERN is happy with that. Higgs fields, exactly what CERN shows. I think they're happy with that. Why aren't they happy with this? Now, when this girl looks at this, she says they're like frisbees coming out at her, all like coming at you, like they'd be way out here. She says she can see this stuff like it's in a depth. There's no flatness to her world. All of these colors are just coming out, and she could pick them out in a different color arrays and where they are. And then this is what really got me. This one here blew my mind, because this, I say, is a reverse spinner, and that is the one that concussed with one of these and caused a mini one of these. Now, in my mind, if it's a reverse spinner, it's an anti-particle. So, what is a particle that is a positive, a real particle? They're coming out at us like this. What would that do? I said to her, and I didn't say anything. I didn't say a word. I said, you see that little white particle there? What do you see there? She says, that looks like it's on the other side of the universe. I'm not kidding you. I'm not kidding you. She said, that is so far away. Now, it's brighter than anything here. How could it be so far away? I'm telling you, she can see this, and this is exact. And I said, you just blew my mind, because that is what I was hoping you would say, that it's the opposite of this. And exactly what she said. It is basically the opposite of this. It is way on the other end of the universe, really. I believe that's exactly what she said. It looks like it's on the other side of the universe. Now, let's look at what she did send me. All right, I've been showing these. They're in the red, they're in the green, and at this point now, I'm working with her to try to help me to understand this, because I see this exact same particle, this little particle here, and I had her look at this, and what she said was she saw what looks like a Jax, and she went and did a whole bunch of research on her own, because nobody's ever been able to help her with this. Well, not help her, but to be able to explain this to her about why she sees this way. So she's very interested. Thank God. We're going to play around with this thing a little bit. Now, I said, what do you see there? Now, that is a high-speed particle coming out of the accelerator. Let me just explain to you what you're seeing. Coming out of the accelerator here, spinning, and then all of a sudden, as it slows down, it's captured in 2 cycles. You can see it. 2 frames of the camera. Now, and I see it in red and I see it in green. So what are we seeing? I see 2 dipoles, a positive and a negative, a positive and negative, back-to-back magnets. Now, if that is the case, and the red is also back-to-back magnets, which could very well be the case, are they both the same particle? One is just faster than the other, or how does that work? Now, I was saying, I'm thinking to myself, they are bigger particles. The red is the smallest, the green is the next one up, and the blue is the big boy. Because the red will never ever displace electrons. It's it's slow frequency. Then you've got a little sizzler green, but it's not sizzler enough to always knock something out of its way. It can go, there's a range of how these things can go. Then you get into the blue, and I don't care, you could drop the blue like a drop of water, and it knocks something out of its way, because it's a monster. That's my take, is you don't have to have a whole lot of power, which is the voltage. With the blue, it just pushes stuff out of the way. It's, when it hits it, even light is voltage too. So don't think, oh, the guy's talking about a wire. No, light coming through the air is also voltage. All right? Voltage is nothing more than an electron or electric potential in motion, and what that potential, the power of that potential dictates the number that is the voltage. And then you have the amperage, which is the quantity of electrons flowing. 2 different things. Your voltage can be increased by restricting the dimension of how much can fit through there, just like you do a hose. You restrict the hose tip, and you get high-powered particles coming out, which is water. Exactly identical to what I showed you in our high-speed particles right here. This is nothing more than the tip of a hose. The water comes in, it has to accelerate coming out the other side. Think about your hose. What do you think is happening there? They are nothing more than particles identical to that, and when they come out, they are nothing more than particles identical to that. Now, in this case, they're all negative, so they don't want to touch each other. In the water molecules, they're polar. There's a positive and negative end. They like to be together. They always want to stay together, so you don't get this coming out the other side unless you aerate it. But in this, you will always get this because they are all negative and they fly away from each other just as fast as they can, and that sets up the stripes. Those aren't from a flappy flap coming through there. That is from a spinning particle. It's spinning to the right, and as it does, some spin that way, some spin over this way, some spin a little bit, some spin a lot. When they get on the other side, they all want to get away from each other, and that's what you get is this.